Welcome back. So we are going to continue our lesson 1 of this module to look at the read and write process in HDFS. So the idea is to explain the write process in HDFS, detail the replication pipeline process, and then look at the read process. So the write process in HDFS is initiated by a client. So circled here on the left, you can see the HDFS client write request. So initially the data gets cached locally on the client, and as it reaches a particular size, like typically a block size, it's going to contact the name node and get more information on where that block should go essentially. So this initial caching, is client-side buffering, and it'll give you better write throughput, and there's POSIX requirement relaxation. So once the name node is contacted, it responds with a list of data nodes, and the name node is rack aware, as I mentioned earlier. So like a default replication of 3, what would happen is HDFS name node would say the primary replica block is placed on the local rack, so rack 1 in this example, assuming that the HDF client is in rack 1. And then the next replica goes on a remote rack, so rack 2 in this case, and the replicas are in red here. And essentially what this does is prevents against getting loss if the rack that you're writing to fails, the primary block fails. And then it protects against failure of entire rack or a node, because you're using an entirely different rack for the second block. Now the third block is on the same remote rack as the second block, and this is so that you're minimizing network traffic between racks. So essentially the client gets a list of data nodes back. At this point, the first data node starts receiving data in small portions from the client and writes to the local repository. The data portion is then transferred to a second data node, which in turn writes to the local repository there. And remember, this second data node is on a remote rack, and then transferred to the third data node, and which does the same thing over again. So essentially the data node can be receiving data and forwarding data at the same time in a pipeline. So what this means is the entire replication process is pipelined, and you're not going to take 3x the amount of time to make 3 copies of your block. You're going to take much less than that. Once all the blocks are written and the file close is done, essentially this process is committed into a persistent state by the name node. And name node is what receives the heartbeat and block reports from all the data nodes. So a circle from all the data nodes is that information. And if there is a failure of a data node, the heartbeat is going to go away, or maybe you get a corrupted block. Either way, you're going to have the name node doing the initiation of fixing that aspect of it. So on the read side, again the client does the request. From the name node, it gets information about the blocks, how they're laid out, and HDFS tries to satisfy the read request from the nearest replica. So you're not basically again trying to basically do local reads, and you're not doing network transfer as much as possible. So this is essentially the crux of how a read and write process works on HDFS. So now that we know this, we're going to look into performance tuning and robustness in our next video.